Welcome. We are today going to understand about piping and instrumentation diagram, is also known as P&ID. So generally, this is P&ID is also known as mechanical flow diagram. It provides information needed by engineers to begin planning for the construction of the plant. So here the plant, we mean the chemical process plant. Right. P&ID, uh, it includes every mechanical aspect, but there are some exclusions from the P&ID diagram. So we need to understand what are those exclusions here. So it does not provide information on, you can see here, operating conditions, that is T and P, which is known as temperature and pressure. Stream flows, that means, suppose say flow rate, how much flow rate is going, it will not be depicted on the P&ID diagram, but rather it can be seen in PFD. And equipment locations, it is not depicted. Pipe pipe routing, and at last supports, structures, and foundations. See, the first two are found in PFD, that is process flow diagram. Again, okay. Now let's go further. Yeah. Now if you see what is required in this particular session is that how do we build or how do we construct a P&ID diagram? So we want to construct P&ID diagram. That means it is a job of a design engineer, planning engineer. So number one is for equipment. What needs to be shown? Spare units to be shown, parallel units to be shown, summary details of each unit. Second one, for piping, so it includes what? There are 4 elements under piping, include all lines, including drains and sample connections, and specify them. And specify what? Something, right? That means piping means it include all lines, including drains and sample connections. We can see in a P&ID diagram where to collect sample, where to actually, which valve will allow us to open, and in which pipe it will allow us to what you call drain the fluid. So you can see here, first of all, suppose a size, so 40, I say size, schedule number, so you can see SCH 40, you can say SCH 80, something like that. Material of construction, if I say, it can be SS. Insulated or not, you can actually see this. So you can write, I'm just trying to show in what representation it will be seen on the P&ID diagram. Still going ahead, we have for instrumentations or instrumentation, instruments. So as the name suggests, piping and instrumentation, piping connected to the equipment, and piping and equipment itself is one part, and instrumentation is another part. So instruments, there are indicators, we represent by I, recorders we represent by R, controllers we say LC or LIC, instrument lines also are to be shown. Similarly, utilities, suppose I have an heat exchanger, It can be a cooling or it can be a what you call heating purpose. This is the process fluid. This is the process fluid which needs to be cooled or heated from a temperature of T2 to T1, suppose say. So this particular line, what you are seeing here, this particular line, this is actually a utility stream. So this is the entrance, this is the exit. So generally in P&I diagram, it is shown as 1 and 2. So 1 is entrance, 2 is exit. Yeah. So let us understand all these things by an example. So here if we can understand a PFD, for a plant, there will be one PFD. For each PFD, there will be many P&IDs. Let me write it again. For each PFD, there will be many P&IDs. So one plant PFD is one. For each PFD, many P&IDs will be there. So let us, what is this example now? Yeah. So benzene process flow diagram. So this is the manufacturing of the benzene. So this is the entire manufacturing of the benzene. I've just made it a little bigger. The raw materials here are, you can see, these are the raw materials. This is toluene, this is hydrogen. Product is benzene and methane, or we call it as fuel gas. This is one P&ID. In this P&ID, what we are looking at is that this particular column, distillation tower, is represented or is in, it has one P&ID. So this is the distillation column. You can see distillation column. So the tower name is T101, and this is the vapor line, and this is the bottom liquid line, right? Okay. Now you can see there are certain things you can see. Now this is, let us say, the piping. You can see here, first is size 12-inch, schedule 10, and then carbon steel. But that means this is not insulated here. So there is nothing given in this particular. Where is insulation? You can see here, this is the insulation, the bottom portion. This is the insulation here. You can see there is a symbol, separate symbol given for the insulation. So P&ID represented in the previous figure provides information on piping, which is included in diagram. An alternative is what? Each pipe can be numbered and the specifics of every line can be provided in a separate table. Yeah, but here what happened is specifics are given in on the line itself without a number. When possible, the physical size of the larger size unit operation is reflected by the size of the symbol in the diagram. See, in the diagram itself, you can see distillation tower is bigger. This is bigger in size than compared to the vessel V104. Here V104 is reflux drum. Now see, this is the utility connections table. One means cooling water. Let us understand where it is located in the diagram. So if I see here, if you go to 1 here, so this is 1. This is 1. This is entering the condenser here, E104, and the leaving is here 2. So what is 1 and 2? 1 is cooling water, 2 is cooling water return. Return means what? Where does it go back? To the cooling tower. So utility connections are identified by number box in P&ID. So there is a number box. You can see here, this is a number box. Everywhere square box is given. The number within the box identifies specific utility. The key identifying the utility connections is shown in the table. So this is the table. Yeah. Now see, what are the conventions used in identifying instrumentation? That means P&ID has certain instrumentation. Suppose I have LE, LT, LIC, LY, LC. So this L, the first letter represents level. Now if I say temperature, I have TE, TT, TIC, TY, TC. See? So this first letter here says the variable is temperature. Now what is this E? Second letter T, second letter I, third letter C, second letter Y, second letter CV. So let's see in what way we can understand. Location of okay. Now location of the instrumentation. So there are three symbols which we can understand. First symbol is simple, a circle. It says instrument located in the plant. That means reading also can be seen in the plant. Second one, a circle with a horizontal line inside. Instrument located on the front panel in the control room. Circle dashed line within. Instrument located on back panel in the control room. So this is one. Second one is meanings of the identification letters. I have said the first letter L. You can see L here. So what is L? Level. Okay. Second letter, suppose I write I. Okay. This second letter, if the same letter is second, so where is I? H I. So this is I. So here I. Indicating. Level indicating. So third letter, if I say C, where is C? C as the first letter is conductivity, but its third or second letter, control. So this becomes control. Similarly, you can actually see others also. Suppose if I say T A H, first letter T, it indicates temperature. This is in the first letter. A is second letter. That means here you can see A is second letter. If it is the first letter analysis, second letter alarm. H is third letter. Where is H? H is third letter. If it is first letter, it is hand. Third letter is high. So this shows temperature alarm high. This shows level indicating controller. So this is what this particular meaning of the identification letters on P&ID. That means generally it is written as X, Y, Y with a circle. Okay, if there is a line below this, that means it will be indicated on the panel, front side of the panel. Okay. Right. Another identification what we require to understand is instrument connections. Whether it is a pressure signal, if it is a pressure signal, directly a solid line. If it is a line with a hash symbol, it shows the pneumatic. Pneumatic means air operated. Third one is electrical operated. Electrically dash. Okay, electrical is electrical operation dash. So now how do we interpret this interpretation of the instrumentation on the control symbols? If you see this in this diagram, so this is one portion of the total distillation column where I have taken V104 and across this, across this, there is instrumentation which can be understood. So what does it say? So let me read this here. Consider the benzene product line. So benzene product line is this, this is the benzene product line. So this is the benzene product line, this particular line. This and this, it goes to pump, from pump it goes to this place and this place. This is the benzene product line. Yeah. The flow rate of this stream is controlled by a control valve that receives a signal from a level measuring element placed on V104. Okay. Explain the sequence of instrumentation. So what is the sequence of instrumentation now? So if you see this, number one, where it is actually showing this, what we can understand is number one is LE placed on V104 level. It is doing something. So first one is LE, second one is LT, third one direct or horizontal line is LIC, fourth one LY, fifth one LCV. Apart from this, there are two more which are which are represented here, LAH, LAL. Let us number this as sixth and seventh. So let me make it bigger. Now you see, this is one is LE, two is LT, third is LIC, four is LY, five is LCV. Six and seven are LAH and LAL. So this is the information flow or flow of the uh, information flow to actually which is placed on the benzene product line. So in words, let us understand what is this in words. A level sensing element. So what is LE? Level sensing element located on the reflux drum V104. So we should understand what is V104 first. Next, level transmitter is also located on V104, sends electrical signal to the LIC. So first one is simple dashed line capillary, solid line capillary action up to LTT. From LTT to LIC, this is electrical signal. From LIC is located in the control room. Okay, the how do I understand this is LIC? So this it is something like this. That means control room and the control panel are console and can be observed with the operator. That means I can go there and see what is the level. From LIC, again, second one is from LIC, electrical signal is sent to the instrument LY. So LIC to LY, electrical signal. From LY to LCV, this is like this. That means a pneumatic or air operated. Ultimately, the final control element is valve. So if I say this is my final control element LCV. So in actual practice, if the level is measured by orifice meter, so this is my orifice meter. So this becomes direct level sensing element. As we measure temperature with thermometer, level is sorry, it is level. Oh, it is not orifice, right? It should not be orifice. So here, instead of orifice plate, I want to measure level. So level sensing element, it can be a one of the dip rod. Here, you can have a dip rod. Okay, a dip rod here in the tank can measure level. Okay, that means based on the density difference, it executes. Now it goes to level transmitter, then it goes to LIC, then again electrical signal, it goes to LY. Ultimately, this LY is nothing but I to P converter or I to P transducer. Now here comes the pneumatic signal. That means air. That means pressure. So here it is pressure signal. Here it is current signal. Here it is current signal. Here again it is pressure signal. So level sensing element sends the what is information. Probably here also we can understand. Here also we can understand this can also be for our easy sake. This can also be a current signal or a voltage which can be sent here. So ultimately, this total thing is actually looking like a loop. So if you can understand, this is total thing is a closed process loop. This is also known as process control loop. You know? If it is temperature, you change every first letter with T. If it is pressure, you change every first letter with P. If it is level flow, change every first letter with F. So now, apart from this instruments, what are the instruments? Level element, level transmitter, level indicating controller, level, you know, what is the next one? Ly. Ly is send instrument that computes the correct value valve position. Yeah. So what is actually giving is this Ly corrects the valve position and accordingly it sets the signal whether to close it or open it. And ultimately you have an LCV here. So this LCV will be in a pipeline connected like this, and these all are connected this way as a loop. Apart from this, from the LT to LIC, there is something called here LAH, LA. That means what? Level alarm high, level alarm low. There can also be something called LAHH, LALL. It depends on in what way we want to understand. Level LAHH means level alarm high high, level alarm low low. So that's all. I think we are able to interpret the diagram now better. So ultimately, the P&ID, that means piping and instrumentation diagram, it is the last stage of the process design. So what is the first stage? It is nothing but BFD. What is the second stage? It is nothing but PFD, that means process flow diagram. Then comes the P&ID. The last one is P&ID. So P&ID is a one. It serves as a guide. So number one is what? It is the last stage of the process design. Number two, it serves as a guide for those who will be responsible for final design and construction. So ultimately, the plant needs to be constructed. The plant needs to be constructed here. So this is something the plant near the seashore. Okay. So this plant, this construction is very important. So P&ID becomes the base. Yeah. So based on this P&ID diagram, mechanical engineers and civil engineers will design and install pieces of equipment. Instrument engineers will specify, install, and check control systems. Piping engineers will develop plant layout and elevation drawings. See, again, this very important diagram comes in here. Plant layout and elevation drawings. So elevation drawings again comes in what? General arrangement drawings. Project engineers will develop plant and construction schedules, the timelines of the process. Okay. This entire information is gathered from the textbook called Analysis, Synthesis, and Design of Chemical Processes, 4th edition by Turton, Bailey, Wallace Whiting, Shabets, and Bhattacharya. I hope you have understood about the P&ID and how to interpret P&ID, what is the significance of P&ID, and what are the, and we have checked with even an example also. All the best. Bye.